everyone, Mike Levin. Saturday, April 23rd, 2022, around 11 a.m. Running some morning errands, and I thought I'd crank out a video because at 51 years old, I take it almost as a personal affront that I am in those set of people who consider themselves not math people. Now, this might surprise some people out there, given how much I do my coding. Recently, my Linux, Python, Vim, and Git talks, and I thought I'd just crank out a quick video, because that's all the time I have, on my recent observations on that front. So, many topics are complex. Now, many topics are abstract, but on the flip side, many topics are complex and not abstract. While things you can do might be abstract, building things upon things upon things, and eventually the way you put it together is abstract, the building parts, the Lego pieces, such as it were, have no ambiguity about them. They fit together a certain way. Here's how they interact. With a little bit of creativity, you can surpass the way they were intended to be used. But for the most part, if you make a mistake, those Lego pieces aren't going to stick together. If you try and push together parts that don't have the little bumps coming out to, each other, they'll slide apart. Of course, there's no cohesion. So there's a very hyperliteral, I use the word hyperliteral quite a lot, a hyperliteral rule regarding Legos. And if you don't do it right, they're not going to stick. So, what does that mean? What am I even saying there? Well, it happens that I've been handicapped in math. I realize from high school algebra. It's high school algebra 1 that does it. They give you a rule that numbers can be represented with variables. Okay, good enough. That's the same as programming. It's a hyperliteral rule. And then they say, when you want to multiply two numbers together and get their product, this times that, you can put a dot between them. That's one way. That's one of the mathematical operators. We learn it in lower grades as the little x. This times that, that many times. X is good. It seems like a good interface. An API is what we're talking about. And then yet another one is putting those two symbols, the two things representing a number, like a number and a variable, right next to each other, like 2a. And it implies multiplication, 2 times a. And if a contains the value 4, 2 times 4 is 8, and the result would be 8. Again, nice hyperliteral rules, or so it would seem. Now, the actual situation is that when you have multiplication, it varies what you're going to be looking at. Sometimes there's a dot, sometimes there's the x, sometimes there's an asterisk, yet another multiplication operator, and sometimes there's nothing at all. And then one of the next things you learned is that variables can have multiple letters. It's not always x equals 1. It can be, Sally equals 1. And that's another thing that you have in programming. Now you have to override any tendency you have to say that's S times A times L times L times Y, right? The hyperliteral mind that has sunk its teeth into the rules that putting letters next to each other has implied multiplication has to overcome that to say no. S-A-L-L-Y belong together as one atomic unit. And you can multiply Sally times 2 or times 4 or whatever, but Sally itself is the symbol. It might as well be just S. Now, you have some different rules that you have to switch between here. And right there, I hardly even need to discuss it further. This kind of thing, the rules regarding when you switch rules, the flexibility, the abstractness of the thing being in the APIs, the interfaces itself, has destroyed me for math, plain and simple. The rules of high school algebra are not consistent in higher level maths when other things start getting introduced. D for derivative in calculus. So now you have another letter whose position and upper lower casedness and has a different meaning. It's not times D. You have to get over that. In algebra 1 notation, calculus notation is very confusing, right? So, because maths build on maths build on maths, and this chain of dependencies and the shifting and changing APIs and the context sensitivity is so stateful. It's stateful. If it were put in programming terms, math, the whole field of math, is not functional at all. Functional programming has no side effects. It only does what it says it does. There's no extra things you have to know. Once you look at a system, a function, whatever, what have you, values go in, values come out. The syntax of the language is fixed, and so you know what it does. There are no mysteries. There are no hidden APIs or things by implication. That is math would not be a functional programming language. Math would be more like, it's not even procedural. I like procedural. Python is mostly procedural, even though Python lets you work functional with no side effects. It mostly is, functions that call each other's values and are allowed to have side effects, which is called procedural. I mean, this is, even programming doesn't have great language. The labels are terrible. But then another type of language is called imperative. Imperative is like SQL or HTML, where stuff is thrown up and how it gets done is up to some other thing that you don't see. The procedural process is hidden from you, and it's certainly not functional because there's no, values being fed in and out of things. It's just, here it is at face value. It's a lot like writing in English or some other spoken language, an imperative language. It's imperative that you do this. I implore you to make this web page show. And imperative languages tend to be much easier because you don't have to know much about implementation, about, how it gets done. And hence the vast popularity of HTML and SQL, two imperative languages that have come to rule the world, right? If math were even imperative, it would be nice. Math is this other thing where, okay, so here's the idea. Programming has it too. APIs shift and change. APIs shift and change within the same language when you import libraries, and pandas or pathlib or whatever have you writes all over the API, changing how, the slice notation works in the case of pandas, or changing what the slash does in the case of pathlib. So this slash that is a path if you've imported pathlib and are using instances of its objects. Whereas in other, Python situations, that slash would be a divide operation. I'm okay with that because there's the import. Because there's the pandas documentation, and there's the pathlib documentation. In the hyperliteral state that I tend to live in when pushing symbols around, Python lays it out straight. Now, what about other languages? Well, APIs vary widely, radically. Take a look at Lisp again. I bring up Lisp all the time. The very mathematical order of operations. It's one of the few programming languages out there that says, to heck with algebra. So it's mind expanding. What do I mean? Well, in Lisp, you'll have a set of parentheses. You'll have an operator like summation or sum at the beginning of that parentheses. And then you'll have number, comma, number, comma, number, comma, number, comma, number. And what Lisp is saying is take this set, use the thing in position 1 as the operator that applies to everything that follows. Sum everything in this parentheses, so it becomes this beautiful, readable atomic unit that has nothing to do with traditional algebraic notation and order of operations. And again, even though I never took up Lisp in a serious way, I'm okay with that. Why? Because it's the Lisp interpreter space file name. I know that the context of everything in this text file where these symbols are moved around and positioned is going to be operated upon, carried out, interpreted by this particular interpreter. And that is okay with me. So why is the tiny d in the lower right when you're doing calculus different from, x times d next to each other, xd, right? Disney xd. Well, why is that so difficult for me? It's because the lack of anything you can really sink your teeth into context-wise. You're kind of floating in the middle of a big white field, like in the Matrix, in the arsenal, when they say, I need weapons, and whoosh, 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 all the weapons appear. But a moment before that, it was a blank slate. It was whiteness. And moving from that blank slate whiteness to here's what you do and why and how and the rules that govern it and the API that you're using is tough in math, because dependencies of experience. It's not dependencies of things sitting in front of you. In programming, there your dependencies are. There's the import. The dependencies in math are your human experiences that go back in time. If you've been poorly taught, if you've been misled, if someone has failed to motivate you, to lure you into the wonderful land that can be math, then the dependency chain is broken and you are, poof, not a math person. And with my love of science and my love of technology and my love of science fiction and visions of the future and the process of visualizing where you're going and then trying to get there. And here I am at 50 and I have no savings, but I'm guiding my life. I'm I earn really well. I know what I'm doing. So what I do is I make the best out of what the hyperliteral mind can cobble together and compete with those people who are better with abstractions and ambiguity and uncertainty and living off of a chain of dependencies that was built better for them. Now, maybe it's in the person, maybe it's in your own head, and maybe it's in the experiences you've had and the opportunities around you. But it has been told to me I have been let down by those people who had the responsibilities of introducing me to math. And here I am with an 11-year-old child who themselves does not consider themselves a math person. And in fact, it's a triggering word. The word math makes them angry. And hence the patterns are repeated. They are hyperliteral like me. My duty is to entice and lure, and through the clear availability, not the promise of, because words meaningless, but demonstrating the possession of superpowers. My kid likes to ask me, if you could have any superpower, what would it be? And I'm like, I read, and I can reproduce the experiences of other people's in my mind. And I can take the benefit of their life experience without being in the same danger, without dedicating the same number of years to have these experiences, and take those learnings and apply to my life. I have superpowers. And they kept pressing me, and I'm like, okay, look, at 50, I'm getting very nervous because I'm halfway through. I think I'm just getting started. So if I were to have a superpower, I'd like longevity, not immortality, because, with enough longevity, I have the time to decide whether I want to segue that into immortality or not, mortality or immortality, right? So with I think we should all have 100 years. I think that nature, God, or what have you, whatever why things are the way they are, we have 10 fingers because each finger 10 times is 10 times 10. So it entices you into some math operations, as full of lies as it is, because decimal system and everything. But nonetheless, it's a good mental framework. Each finger has 10 fingers. That is an easy way to count to 100. 100 is about how many rotations around the sun we're given. I think we should. I think that's a good aspiration in life. My heart aches for Gilbert Gottfried. My heart aches for Steve Jobs. My heart aches for everyone who was on this stellar path and then somehow was cut short in their 60s. To think I only have 10 years ahead of me when right now I'm like just getting started, and how people like look all Homer Simpson. Maybe part of it's genetics, maybe part of it's lifestyle and outlook, but it breaks my heart. It breaks my heart that we're only given about 100 years if we're lucky. And so my superpower would be times 4 or times 5, because these are two magic numbers in my mind. Every number's magic, every number's special. But 4 quarters in a dollar, 25%. 25, 50, 75, 100. That's an important notion. 4 corners of a square, each being 25% or 1/4 of the value. I think that's a big thing. But 5 keeps coming into the picture. Even though 4 seems very natural, 5 keeps popping up. 4 very natural, 5 keeps popping up. Why? 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. The 80-20 friggin' rule, gotta use it. It's a tool reducing clutter that we pack into our lives that hold us back. %, 25%, 1/4, 1/5. These are good ways of dividing things up, good ways of measuring things. And they're good ratios. And let's see. Where am I going with all that? Yeah, so I'd ask for 400 years lifespan or 500 years lifespan. I'm not exactly sure which, but I think both of those are pretty good. The full Monty would be going for 1,000 years, right? 1,000 years, one full millennia. But it's good to defer that decision. You don't have to rush into the do I live for 1,000 years choice right away. But given science and given genetics and given everything we're coming to know, it's pretty reasonable to think that we'll at least get up to the 200, 300, 400 year range in the foreseeable future. I hope I'll live that long. I am not in the Ray Kurzweil camp of, in that same time period, we'll be imaging the brain and you'll have your immortality through that route. Even though, yes, it's a copy of you and is potentially as legitimately you as the original, because even we ourselves have all our matter replaced every 7 to 10 years, with the exception of a few cells in our body that don't get replaced so often. We ourselves are wholly new matter every decade or so. So is that the same you? Is that the real you? It's the sense of continuity. It's the continuity over time. It's the very thing that makes that math difficult, that makes us, us. It's that continuity over time. It's that dependency chain of our experiences of who we were leading to who we are. So, whereas Ray Kurzweil is like, oh, just pop it into the computer. He's one of the Google fellows, one of the people, well, the person who invented optical character recognition. So we see things like OCR becoming so easy that now in just a normal iPhone, you can just highlight text in a picture and copy it. OCR is like such a solved problem, it's not even funny. That's one of the big boons of real machine learning these days. The same can be said for voice recognition. It's getting better and better solved problem. And I better wrap this up soon, I see, because the errand I'm running is the person I'm picking up is going to be out soon. So, yeah. 400 years, 500 years is just a matter of some genetic tricks. An RNA virus, something not terribly different than what we've done to fight off COVID, will probably double our lifespans. And it'll be the rich people at first who get it. And then there'll be this tremendous social inequity. You know, rich people can live for 200 or 300 years and poor people can't. And so it creates a shutout momentum. That shutout momentum is terrible. It's awful. It's, you know, the rich get richer, the poor get poorer, the Pareto curve, the ZIF, the wealth distribution curve, 1/x becomes more and more true. And that's where I'll wrap up. Linux, Python, Vim, and Git, rah, rah, rah. I'm going to tell you why that's the solution to all this stuff, even for the non-math minded person. Thanks for joining me. Hope to see you again soon. Don't forget to subscribe.